Eigenvalues and eigenvectors. Apparently, be very careful when you are starting out with this question because there's a point where complexity comes in. So remember minus the rest of the number, not just the identity area only. So what does this mean? Okay. So apparently, if you were to remember that the equation is the lambda I, the identity matrix minus a equals to 0. One typically for me, when I write, I just write all of these things. Okay. I use it like correctly. Or however, when you because this is the form when you start when so this okay. But however, when you are doing this from this you straight away do this first, and then for me, and then I straight away do this first, and then I straight away copy all these things down. I didn't realize that I have to minus. I forgot. So I just keep doing and doing, and I got a wrong answer. So this is a very dangerous mistake, complexity mistakes. So apparently what you need to do is to minus, is to change out this whatever thing that is not included with the lambda. So you just change the signs. So it's just minus 1, and which is what we are over here. Okay. So this is a very important understanding that I need you to sink in. So apparently so without further ado, let's start. So the first step is to use this equation, and then you just do in terms of this. And then we use the rules of Saurus, where the green arrows, okay, when you multiply green arrows is in this direction, you just multiply them in this manner. Okay, minus 1 times minus 1 times 0 equals to 0, and then so on and so forth. But however, do take note that the green portion minus away the blue portion, okay, slanting to the left side, the blue color, is minus, okay, green minus blue, it's not addition. So this is just only one thing that you need to take note. You can, however, alternatively, you can also use the determinant method. But however, the determinant method always has class mistake, so I decided to use the rules of Saurus. And then eventually you will get this thing. Okay. Once you get this thing, you have a third order quadratic equation. However, you don't know how to decompose it, right? So we apply a synthetic division. So this is where we are here. So there is three types of things. So the first one is to be careful of the complexity, and then you apply the rules as always, and then you get a synthetic division. So synthetic division wise, we just, as you can see, this is lambda cube minus 2 lambda square minus lambda plus 2. You just take all the coefficients and then it's plug it here. So it's 1 minus 2 minus 1 and 3, right? Okay. So for the first step you do is you pull this 1 down here, and then you just guess any how do I say any eigenvalues. So apparently for this portion we are trying to guess, we're trying to figure out the eigenvalues so that we can find our eigenvectors. So now for our case we guess 1, okay, lambda equals to 1. So we just do and make sure that this portion is equals to 0. You don't want it to have any remainders. If you have any remainders, this means that your method is wrong in this case. Okay, it's not exactly wrong when if you for other case you have remainders, never mind. But however, for this case, if you have remainders, then you have something wrong lah. Okay. So apparently, if you were to do that, you will eventually get this, and you can straight away decompose with your algebra simple tools. However, one key note I need to convey is that you have to guess the proper one. So let's say if you guess 2, okay, so let's say we guess 2, okay, and then let's bring it down 1, okay, 2 times 1 equals to 2, you'll get 0, right, and 0 times 0 equals to 0, and then so you have a remainder 2, which is, so this is what I'm trying to convey over here, okay. So after which you get your, after which you get this two roots, and you know that your first guess lambda equals to 1. So you finally know that your three lambda values are 1, your first guess, and 2 minus 2 equals to 0, and minus 1 plus 1 equals to 0, which is this. So this is what it is, and then after which we can start to solve our eigenvectors corresponding to this our eigenvalues. So if our lambda equals to 1, our eigenvalue equals to 1, you can straight away sub in into your lambda equation. So into this equation, if you remember, okay. So forming this equation is very important. If you, as I said earlier, and trying to how do I say, stress on it that please be careful when dealing with the negative sign. Okay, when you're minusing, you're trying to minus away other thing. Okay, just be careful with the sign. Okay, so you just sub in into your you just sub your lambda in, okay, and then you just eventually get this. And do take note that this thing multiplied by x, y, z equals to 0. Okay, as you know, the equation here is lambda I minus a equals to 0. So this is what it is. And then now in this, in many situations we are dealing with a lot of unknown solutions. So the method of doing with many solution one is okay. So let's say we have, you can see that these and these are the same. So there are many, so this would infer that there is many solutions. So what do you do is that you can take these two and then you just do a relationship with each other. So you know that this is in fact minus y plus 2z, okay? 0 times x equals to 0, minus 1 times y, and so on and so forth. So minus y plus 2z equals to 0, and then 2z equals to y. Now the important point comes in, okay? So I actually did take down when we are dealing with how to use the manual solution technique. So this is the technique I'm trying to convey, and I hope you can understand. So if y is equals to c, so let's say you know that 2z equals to y, and let's take y is equals to some constant c, and then therefore 2z, okay, 2z is equals to c, right? If y equals to c, so therefore z is equals to half c. Okay, I actually forgot to write the c. Alright, so now take row 2 equation. Okay, so what I mean row 2 equation is that this is the equation where you have fully x, y, z in there. So this is x minus y minus z equals to 0. Okay, therefore since we really know that y is equals to certain constant c, and z with regards to this relationship is half c, then we can just sub it in and find our x. So x is actually 3 half c, and therefore if you were to write down this thing, you have 3 over 2 c, and y equals to 2 over 2, which is 1 c. I'm just trying to do it in this manner, so later you will know what I mean. So therefore if you factor out the c, you get this manner, and then you just factor out the coefficient of 2 or half, let's say, you get 3, 2, 1, which is the answer. Okay, so this is what it is. And for lambda equals to 2 is the same thing. So let's explain also. So similarly, you just sub in your lambda equals to 2 into the equation. Eventually you get this, and then you solve for c1. Now this matter, now this situation is that you have known conditions, or rather as you can see, you can visualize it straight away that they are the same, right? So we are trying to, if they are the same, if two equations are the same, this means that there are many solutions. However, in this manner is a little complicated, so you need to do simultaneous equations. So therefore, if you were to, this is the same as this, and then if you were to do some simultaneous equation by the first row minus the second row, you will get this, and therefore you can see that they are also the same. And therefore you need many solutions, and therefore this is the many solution form. So similarly, using the same technique, okay, be careful, be extra how do I say, alert that this method is very important, as I always forgot also. So therefore, you just sub anything that is constant, anything that there's no coefficient. Let's say this is 1y, that's why you take this as c. You can also take 2z equals to c, but it's a little it's troublesome. So let's take y equals to c. Okay. So apparently, similarly in this case, for our case, previously is this one, right? Now we talk about this, the second, the lambda equals to 2. So with this set, we can take this relationship, which is minus y plus 3z, okay, if you remember, or minus, if there is a xyz, sorry, my, my pen, okay, this is x, y, z. So apparently if you were to multiply 0 times x, 0 minus y, minus 1 times y equals to minus y, and then 3 times z equals to 3z, that then. So this is what it is. So therefore, we have minus y plus 3z, and we have the relationship between these two variables, 3z equals to y. And therefore, let's sub in y equals to c again. So if y equals to c, then therefore 3z is equals to c also. And then z equals to 1/3 c. And then with this set, we also know that there is another equation over here, which is with containing three variables x, y, and z. So therefore, since we know y and z, things are easier. So you just sub in your y and z into this equation, and then you can straight away find x equals to 1/3 c. Now you know x, y, z, and you just write them in terms of the coefficient. 1/3 c, and then y equals to 3/3 c, which y equals to c. So in other words, 1 equals to fraction 3/3, I think. So yeah, so you get this. And similarly, for the last one, if lambda equals to -1, you can straight away use the same method. You just sub it in, and then you just do all this simultaneous equation, and you realize that they are also the same. For this case, it's different. So apparently, there is no two variables, it's just one variable. It tells you that okay, -1y and -7y is equals to 0. So therefore, y is equals to 0. And since y is equals to 0, and you have this three variable equation over here, so just sub in y equals to 0, you'll get -2x plus 2z equals to 0. And therefore 2z, this bring here is equals to 2x and z equals to x. So now we do now we do the same thing again. We just sub in z is equals to any constant c. We take z as any constant c. And then since z is equals to c and z is also equals to x, then z is equals to c equals to x. And then x equals to c, y equals to 0, as we know over here. Okay? And z equals to c, and therefore we have 1, 0, 1. Okay? So if you were to go to the Wolfram, okay, maybe you can type eigenvalue calculator 3 times 2, and you'll get your values. Okay, just sub in, you just plug in all your stuffs. Okay, and then you'll get your values. It's the same. So if you want to practice and you want to know whether your answer is correct, you just put it over here. Okay, so this ends my video on eigenvectors and values. If I have time, I'll just do a question with step by step. Okay, so see you.